Good evening, everybody. Welcome to Advanced Refrigerator Podcast. You're here with their hosts, Brett Wetzel and Kevin Compass. Kevin, what's going on this week? What do you got going on?
Well, last week was a lot of just like cleanups. Well, this week technically still Sunday. It was a lot of cleanup stuff, just knocking out some punch lists at stores and cleaning up a couple construction jobs, and spent all week, the end of the week, changing out some CO2 pumps and knocking out some punch lists at a store. And I've also spent all weekend at the same store on the phone because it just continues to hemorrhage CO2 out everywhere because of some manufacturer and control issues. But yeah, that's been my week. What about you, Brett?
I did trading this week. We were going over pump liquid CO2 and some glycol stuff. And then Friday, I was really excited. I hadn't worked on a train tracer system for HVAC in quite a while. And I was like, oh, I got this. And I just got my ass handed. Like it took me, this train's so proprietary with everything they have. And it took me probably about 30 minutes to actually get software working with what we had. And then trying to figure out what's going on. And this is after the guy at the place was like, yeah, train's been in here try to get it working. And ultimately what I think there's conflicting information between the new rooftop that they put in and the old program, where it's looking for a differential across the static pressure, and it doesn't have that information. So it's basically just not allowing the rooftop to come on. And I hate to say it, but I don't like it. I hate feeling that I haven't got anything accomplished, and it's been a while since I had that feeling. And Friday night, I just felt like crap. I was like, I'm useless. I can't do anything. And I'm done. I'm done with it. I don't know what to do. There's some kind of deep rooted program that needs to be done from conception. Otherwise, we could just rip it all out, put some ET stuff in there, and we'll be straight. Just get some Belino valves to adjust all the VPs, set it up, and I'll be straight. So,
yeah, with stuff like that, I mean, you're pretty much screwed unless you're the manufacturer. I mean, it's so proprietary. I mean, even though you have the software, you probably don't even have access to get to where you need to go.
And that's the other thing. Like I was only, whatever the password was written down in there was priority 8, and there's like priority 13. So I knew there's some kind of deep rooted stuff that I don't even have access to. So I tried valiantly for trying to go through all the programming, and I'm like, you know what? I'm done. Can't do it. But enough about HVAC, because I'm going to cry inside a little bit. But we're going to be talking about frozen food refrigerated cases tonight.
Mostly troubleshooting and defrost stuff with them, kind of like we did with the last podcast with the open air cases, and we touched on like how to start the service call with the racket stuff. I mean, we're going to go over some of that stuff just briefly, since we already went over it in the podcast already with what to check. I mean, the stuff to check is pretty close, but like there's some nuances between obviously the defrost and some other things to check on frozen food doors that we normally wouldn't have issues with on open air cases.
All right, go ahead, start us off, boss.
Okay, so same thing with the other service call or service calls on medium temp cases. When I get a service call for a low temp case or a freezer, same thing. I'm checking in with the store, talking to the store manager, seeing what's going on, what they have been having for an issue. I mean, obviously you got to take what they tell you with a grain of salt, because I mean, you're there and you're costing them money. So what you guys are always here is 90% of the answers. So what you're going to want to do is, figure out what's going on with the case, go up to it, and if it's running warm, if it's too cold, if it's icing frames or whatnot, or issues with doors. But you're going to want to look at the case first. First thing I want to check is the airflow. Do I have airflow? I mean, is it weak airflow? Are the fans all running? Is the case a complete frosted up mess? Is there frost everywhere? Are all the doors closing or one's sticking open if it's frozen food doors? you check the actual temperature in the case with a thermometer. So that way, when you check all this stuff real quick, make sure coil's clear ice, 100% clear ice, and you actually have airflow. I mean, then I'm taking a walk upstairs to the machine room or in the back, wherever the machine room is, to check the rack. Because now that I know the case is iced up, it's a refrigeration issue probably. So it's time to go look at the rack and make sure the rack's running 100% efficiently and how it's supposed to before I start checking superheats and cleaning screens and stuff like that. I want to make sure the rack is running the way that it needs to be running before I start going through all that.
After you check to make sure, while you're in the controller, checking to make sure the temperature is straight with what you got, making sure that the defrost schedule is imperative. Making sure, because a lot of time with frozen food cases, you are also going to have termination temperature sensors, and making sure that those are also reading right, because that can affect how the case is going to defrost. Defrost termination temperature sensors always want to be set for min. If you think about it, it's almost like if you have 3 different cases, 3 thermostats in a row, the last one that's going to basically close the circuit, terminate, would be the lowest one. So you think of it in that terms, it's always going to be the minimum temperature. Not average, not highest, obviously. We want to make sure it's always set to min. Making sure the program is right. Making sure the case isn't going in defrost too long. Sometimes with electric defrost and hot gas defrost, I have different standards that I do as far as what I do and as far as defrost. With electric defrost, I usually go half of the full defrost is versus what the defrost max time is. So if the max time is an hour, I'll usually go for min defrost termination. I'll usually go about a half an hour. If it's hot gas defrost or cool gas defrost, I typically do usually about a quarter of what the full is. If you don't, a lot of times what can happen is it'll just sit there and just keep cooking and just keep heating up and potentially causing more moisture to build up inside the case than what you really want. You got anything to add, boss?
Yeah, I generally do the same thing when I'm going through defrost programming and stuff. I usually shoot for half of whatever the defrost is, so that way if you do have a failed term sensor, you'll ice up, but maybe not as bad. If you get a term sensor that fails, I mean, same thing with why you want to be set to min, because if you do have a term sensor that fails, say you get one that fails reading 120 degrees. Well, if it's reading 120 degrees all the time, every time that case goes in defrost, it's gonna really affect the average if it's at the average or highest, and it's gonna term out right away. So that's why that minimum defrost is really important, to make sure that you still get some defrost, and then that minimum will ensure that you're going to get an entire defrost on the case that has the most ice accumulation on it. If a door's sticking on that one, or if a coil's closer in a walk-in to a door, that way it defrosts all the way and doesn't it doesn't get dragged down all the other cases with it. So that way it's getting a full good defrost. Same thing with one thing to really check. I mean, especially if you're having defrosting issues at a store. Like, if I look at a store and it's got multiple defrosts a day for glass doors, I know something's wrong. They're hiding something. Something's not set right. There's environmental issues. But glass doors should only need to run the spec defrost of an hour. If you're running more than an hour of glass doors, you're hiding stuff. There's a defrost issue, a piping issue, a rack issue. I don't know how many times I come to a store and you look at the defrost schedule and there's multiple defrosts a day, or there's overlapping defrosts. Well, with hot gas, that doesn't work very well, if at all. I mean, if you're trying to defrost 2 hot gas circuits at the same time, unless you have some kind of monster rack with a ton of capacity and a ton of load, it's not going to work.
It's usually the rule of thumb is in like 5%. You don't want any more than 5% in the rack as far as hot gas or cool gas going in at once.
Correct. It's like 5 to 10% max. I mean, 10% would even be pushing it. That's why when I do like my defrost scheduling and programming, I will try to put a large load with a small load back to back So that way, when a large load comes out, a small load goes in, or vice versa. So that way, there's still enough load on the rack to start defrosting the next circuit, and you take away enough load on the rack to not spike the suction pressure when you're turning the circuit that is defrosted back on. So you want to do them consecutive, and you always want to do hot gas defrost at night. So usually I'll start when you want to do when the load starts coming off the rack, like when it starts cooling off at night, because obviously hot gas defrost costs energy to run. It's not free like everybody thinks. I mean, you have to elevate your pressures a little bit in order to pull this off. So it's better to run at night when it's cooler, and it's going to affect the rack performance less. So from like midnight to I don't like going any more than like 8 or 9 a.m. on cases. When you start warming up in the summer months, it's really going to affect you. So I'll go from 10 p.m. to 8 a.m. and try to get all my cases defrosted. Obviously, walk-in coils you're going to have to defrost throughout the day, but I would try to take your large loads and defrost them at night. What's your thoughts on that, Brett?
I agree, and then you're dead on saying you want to stay away from really stop at around 8 or 9 o'clock, because usually by then you have the that adding an immense load. And I've already found where some facilities where they start even earlier loading the cases, you'd have to actually basically sometimes plus schedule according to when they load, just to get so the case doesn't go off on where it's slow to recover, because they basically have had the door open the whole time where it's trying to pull down after that defrost. Usually I will check out the graphs since I'm already up in the motor room, seeing what the difference is basically from when the time I went to defrost, from the time it pulling down, to make sure, this is obviously on the case of alarming, but making sure that one, the other one that was maybe having the defrost issue is coming down as evenly as the other two. Because sometimes that'll give you a clue that something else is going on, whether it be blocked up filter dryer, whether it be something wrong with the expansion valve, whether it be air infiltration. Some of these older cases, Husky cases, can end up having infiltration, not necessarily just from the doors or the gaskets, but basically where the case is actually built, where it's manufactured, where the bottom drain pan actually meets the back wall. We've had, usually when those cases hit about 12, maybe 10 years old, the seams start separating. You'll see ice build up on the back of the actual frozen food case.
Yeah, that's a big problem with when cases start getting older, start getting the seams to split. Well, one thing I really like with it, Brett was talking about the termination. I try to graph out my terms and make sure that they're hitting proper term temps. Make sure they're not terming too early. I mean, if you see them terming real early, and it's just about all the cases in the rack, it seem like they're terminating really early. One thing you need to check is your defrost differential valve. If your defrost differential valve is set too high, what ends up happening is you end up pushing too much hot or cool gas through the coil too fast, and it doesn't pick up any of the heat, or it doesn't absorb, the coil doesn't absorb any heat from the gas or the cool gas to actually cool it down and start melting the frost. So it could end up flowing enough gas through there. I've seen them where defrost differential valves are set to 40 or 50 pounds, and there's gas flying through there so fast that it's just terminating right away on the term sensor, because it's not even getting a chance to, after 3 to 5 minutes, it's already reading 60 degrees, because it's not picking up it's not absorbing any of the heat from the discharge to the coil from that ice. So you really want to have your defrost differential valve set anywhere from 18 to 30 pounds. I don't like going over more than 30 pounds unless I have a ton of liquid rise. So if I have a machine room that's on the roof and it's 25 feet up, I may go with a 25 pound, 30 pound differential pressure on my DDR or LDR. But the lower you keep that differential pressure, for the most part, as long as you're defrosting, the better off the rack's going to run. You start cranking up that differential valve, it's just as bad as having no differential at all, because the gases flies through there, and you end up affecting the rack, because instead of getting liquid back to the rack from the defrost, you end up shooting hot gas into the header. It's the same thing as over defrosting. Once you condense that, once that you're no longer condensing any liquid back from that discharge gas from that defrost in that coil, and that coil's clear of frost, now you're throwing discharge gas back in the liquid header, unless you have a discrete header rack and it's putting it back in the condenser. But I mean, there's not too many of those out there. So you just need to really pay attention to your defrost differential valve settings. Usually you got to run what the spec is for the store, but I like 18 to 25 pounds. What's your thoughts on that, Brett?
No, I agree. As long as you're farthest case out, usually the racks in the back of the store, usually bakers front. As long as that farthest run on the hot gas or cool gas line is defrosting, 18 pounds, which should be sufficient. It does prevent it prevents the rack from causing a higher differential, less energy consumption, and just all around the rack's just going to run better, because you're not sailing that gas through so fast that you're not picking up any of the cold off the coil and letting that gas actually condense. Because you got to remember, it's the latent heat exchange. It doesn't matter how hot that hot gas is. It doesn't matter how high the pressure is. It's basically the amount of controlled flow, right? And remember, with hot gas and cool gas, typically your defrost termination is on the dump line. Now, when we talk about the dump line, usually in most systems, not every single one, but in most systems, hot gas is introduced into the suction line, goes through the coil, goes through the coil. Now that gas, whether it be superheated or just almost saturated, will end up going through the coil, and that refrigerant will then pick up the coldness from the coil and basically condense the vapor into liquid. That liquid is then going on out through the distributor. Normally, the nozzle on all your medium temp stuff is typically right at the edge. So when the refrigerant comes out of the TXV, it goes through the nozzle, and then turns in that perfect mixture, and is dropped into the distributor tubes. When you have a hot gas line, you want to make sure that distributor is back closer towards the TXV, because when that liquid comes out of the coil, after we've injected that hot gas into the suction, and it's coming out the distributors, we don't want to have any kind of restriction there, because one, it's going to reduce how fast what was actually going to defrost, but also as well, we don't want to basically turn that liquid that we have that's supposed to be going back up to this liquid header, turning back into a vapor. So we want to make sure that distributor that is in there, the nozzle is closer to the TXV, not that it's restricting that liquid flow. Then what's going to happen is that liquid's going to come out the side port of the distributor, and then basically go around the TXV with a check valve pointing up towards the rack. The lines are going to meet back, whether it be right before the TXV or right up where the liquid actually comes in. Basically, then the liquid is going to get back up to the rack, and the 5% of the rack that you were now bypassing from the condenser that's supposed to be in the condenser goes in through the coil and then gets redistributed up to the other cases. So there's not a gap in any kind of liquid supply going out to any of the cases. That's why cases that end up going into defrost too long will cause certain cases on the loop to not get enough liquid, and cause slow recovery. You might have one case that has nothing to do with any of its operation, except for the fact that the case before it or the case after it is basically taking that liquid feed away while it's trying to come out from its own defrost, and then end up alarming out because it's not getting an adequate supply of liquid in between the defrost. Anything you want to add?
That's a really good explanation. One thing I want to go over, because I typically tend to see this a lot in some older stores, is guys will start having defrosting issues, and they keep adding time, or this and that to try to add more defrost. I really dig into stuff if I see more than one defrost a day, and if it's more than manufacturer specs. We had some stores we did some commissioning work at, and when I started going through the controllers, I found a couple lineups with three hot gas defrosts a day for 35 minutes. So this is on an older rack. I mean, this rack was running pretty high discharge temps too. So I mean, right away I knew something wasn't right here. We start looking into it further, and I pulled a couple of the cases, got down by the TXV section, and figured out that these cases used to be electric defrost. Well, some genius got the idea that they didn't need auxiliary side connectors. They just put in T's between the TXV and the distributor. Never going to work. I don't care what you say, it's not going to work, because you're never going to flow enough hot gas back through there to efficiently defrost that coil without extending it and doing it multiple times a day.
Oh.
So when you find stuff like that, like we ended up repiping all the three, it was three lineups of 3 cases each. We had to end up putting auxiliary side connectors in, and voila, the problem went away. That probably cost that store thousands and thousands of dollars in energy costs and service calls, all because of that. I mean, these cases were like 8 years old too. So they've been icing up for 8 years.
And they just kept extending the defrost.
Yeah, guys would extend the defrost out. Then while this whole thing was going on, they also were starving cases during this because they weren't getting enough liquid back to the rack from the cases defrosting, because they couldn't flow enough backwards through the distributor orifice.
Yeah, so it wasn't getting redistributed up to the rest of the cases.
Correct. I mean, they had done just about everything they could besides putting the proper distributor auxiliary side connector in. You got to really watch, because I mean, some of these auxiliary side connectors, is kind of hard to tell if it's copper, because I mean, the Sportland makes one, it's brass, and they make one that's kind of copper colored. It's hard to tell after it's been in the case for a while. So I mean, you just got to really look at it, I mean, to make sure it's not a T. If it's a T, then it's wrong. You can't use a T. You have to use an auxiliary side connector. I mean, I've seen that trip up guys time and time again, and you know what? I've found it on new startups too. I found it, the manufacturer sends a case out, and it's 1 or 2 random cases, and somehow there ends up being a T there instead of an auxiliary side connector.
Either that, or they put the auxiliary side connector the other way.
That's happened also, or that ends up somewhere else in a case. I haven't found that yet, but I'm sure. I mean, these manufacturers never don't surprise me. So, so yeah, that's one thing that I really like to push on guys, is making sure, I don't care if it's a brand new store or a brand new case, I want that checked, especially if the case is icing up continuously. I want to know if that's actually got an auxiliary side connector in there, because I mean, if it doesn't, it's not going to flow enough hot gas through that distributor orifice to properly defrost that coil. So that's one big thing to check out. And I mean, if you are icing up, so you want to make sure that your sequence of operations is going through. You want to make sure you have a drip time in there. Some cases, especially Hill Phoenix cases, run like 14-minute drip times. So they're extremely long drip times. So please, like we said before, look up the manufacturer specs. If you don't know what the specs are, you're not going to be able to effectively fix the case. So you need to know what the specs are actually supposed to be and what they are before you can actually try to fix the case. So make sure your hot gas valve's opening all the way, and make sure if you have a liquid line solenoid, there has to be a check valve piped around it on the rack. If there's liquid line solenoid needs to have a check valve piped around it. If there's one at the case or the walk-in, there needs to be a check valve piped around it, unless it is a CME valve. So especially on older Hussmann Super Plus racks, those are all CME liquid line solenoids. Now you need to pay attention. You cannot rebuild a CME valve with an ME valve rebuild kit. And then you also need to pay attention when you're replacing one of those valves. If you replace a CME valve with an ME valve, it's not going to defrost properly, because CME valves have built-in check valves in them that allow the liquid to flow backwards during defrost. So I've seen it on a couple retro or rack changeovers where guys are adding circuits and stuff. and they put in ME valves where a couple CME valves were because they upsized the circuit or something, and they can't defrost properly because it's an ME valve, not a CME valve. And that CME valve needs to be energized for it still to work properly.
Correct.
I believe that's correct, isn't it, Brett?
Absolutely. So we had a problem where one of our stores had changed the program, and usually on those type of racks, the liquid line solenoid is nowhere near any of the relay output boards commanding itself to be on or off. In this particular, there was like one or two racks that were, and they were changing it to the liquid line solenoid turning off. And that, in fact, was doing exactly what you're talking about, where basically the CME solenoid stands for bi-flow check valve. It allows flow to go in either direction as long as the valve is energized. Well, when they were de-energizing it during defrost, a bunch, almost every single case at the store were not defrosting properly, and causing numerous amounts of issues. If you're ever curious, because realistically, it's kind of hard to tell, like, the difference between a CME and a valve. A lot of times, the tags at the top of the valves are gone. Someone had to replace the solenoid coil at one point, and the tag's just laying in the bottom of the pan of the rack. Normally, you can see there's a lightly etched in CV on the side of the actual solenoid body. If you don't know if the valve had been rebuilt, if you pump down the system and remove the guts of the valve, you'll actually be able to see a normal solenoid in the middle where it actually seats on the body of the valve to close it. There's usually only one hole. If you see two holes in the back assembly, and towards the top there wouldn't be just a regular brass piece at the top where the closure spring seats in. It'll actually be plastic. If you see those two things, two holes in the bottom and a plastic piece of plastic piece at the top, you will that is definitely a CME rebuild kit. If you have a CV check valve that is supposed to be in there and you find that it's just a regular gut on a M10 or whatever, then you know that they had rebuilt it typically after remodels, because they were supposed to replace all the gaskets and all the O-rings in the rack, especially if they're going from mineral to polyester. So be advised that there is ways to tell, but they're very, very slight.
That and the body will be stamped CME.
No, CV.
Oh, see, yeah. One other thing I wanted to go over is, since we're going over the hot gas issues, is the individual termination in the Hill Phoenix cases. And you start to see this more and more with other manufacturers. So they're doing individual case terminations. They still have the case termination for the rack, but what they're doing is, for hot gas defrost, they're putting a solenoid on the dump line. So the dump line would be your line coming out of an auxiliary side connector. Then you have your check valve. Then they're putting a solenoid there, a normally open solenoid, so that way they could shut off flow to that line off via a Corel controller or a Dixel controller. They're using a controller on there to individually terminate each case, so that way it doesn't over defrost and cause frosting issues with inside the case from getting too warm. They were doing this with electric and hot gas. With electric, they're just cycling a heater relay, so on and off. But for hot gas, they're looking at the dump valve temperature, and they're actually cycling that. And they're also using that to control their fans now, instead of using a click-on, which a click-on has a kind of a higher failure rate. So they're using those. There's another advantage to those, because hot gas, if you're not piped correctly with hot gas, which that's what we're going to go into next, about some hot gas piping to check out. If you're not piped equally for hot gas, and it's not piped correctly, and it's kind of piped poorly, and the headers aren't blown up right, you're not going to get equal flow through there. And what ends up happening is one case defrosts more than the other cases. Whatever has less resistance on it, it's going to defrost first. So this is something that is kind of an advantage. So if you have, we've had a couple stores. I mean, I've talked to Brett about this one before, where we had like 10 cases on one system. And I mean, it was a terribly designed, piping job, a terribly designed case layout that this customer came up with, but it's what they wanted, and it's what some other contractor did. They basically had 3 5-doors in a row, and they had like I don't know if it was 6 or 8 2-door end caps, like on the ends of every aisle. So what was happening is, I mean, when we got there, it had a 50-minute defrost 4 times a day. They couldn't defrost these cases properly. So the 2-doors turned like right away. And then somebody went through and took all these the Dixel controllers and raised the terminations at 90. Well, the 2-doors would defrost right away because they have less resistance and flow on the piping, and the 5-doors, the last 5-door, almost never defrost. I mean, this thing should have been split into 2 systems for it to be correct the way it was. But me and another guy came up with, we ended up lowering the defrost terms down to like 48 degrees on the 2-doors. They would defrost within like 10, 12 minutes, and then the 5-doors would start defrosting. If we wouldn't have had those solenoids in those cases, it would have never worked pretty much at all. It would have worked how they had it before with the 40-minute defrost, and it was icing up cases at 2-3 times a quarter. Well, it went down to that to them. I think those cases of ice, they've had a de-iced 1 5-door, and that was it all summer long last year. Whereas instead of them pulling it every 2 weeks, we were able to do that because we were able to change the termination on individual cases in order to get deep gas to go to other cases. I don't know if you've ever messed around with that, Brett.
I don't even want to really talk about it. I had a real bad. I had 94 feet of coffin case that was piped up to one header, and I did the right thing. We repiped the whole thing, and it still was ending up restricting flow to the case that basically had more restriction, and then just like you said, the 2 end caps were the ones that got the flow straight away all the time. Those were the ones that ended up cooking the product, because you got to remember the fans stay on the coffin cases unless they're an older Tyler version or an older Hill Phoenix version where they actually have a fan clicks on that does shut off eventually if the coil gets too hot, comparable to like what you said with the termination where it actually stops the flow of gas, where that's so much better, because then you're actually able to take that hot gas or cool gas the burner actually needs to go. And that's what ended up ultimately really fixing that issue, where we repiped it the way it should be, and then we ended up going with dump line solenoids on all the cases just to direct the flow of hot gas to where it needs to. So basically, a whole bunch of normally open solenoid valves and a whole bunch of A19s basically strapped onto the dump line. So as soon as it got up to termination temperature, we knew that where the frost or the ice was clear. Basically from there, close that solenoid, and then all the gas would go to some of the other cases that we're still having the problem. Like you said, there are some customers that just, this is going to look real pretty and it's going to save us money on piping. And ultimately, it just doesn't work. I mean, 94 feet of coffin cases is utterly ridiculous. It should have been split into 2 circuits for sure.
Not to mention, I mean, the actual load on the rack would have been tremendous for it to lose and then come back. You're talking something that could bang on 4 pumps when it comes out of defrost, or something that almost never defrost. That's like a rack I looked at 2 weeks ago. I think I talked to you about it, where it was a newer Hill rack, and it had 3 circuits on it, and it was hot gas. It had 2 24-foot coffins that were dual temp, so one of them was running medium temp, and it had 18 glass doors. This rack, when it was 10 degrees outside, I had the discharge line shut off. I had it in hot gas. I had the A9 cranked all the way in, and I could not get the discharge pressure over 95 pounds, and it was 404A. That's it. That's all she had. She wasn't given any more. And then I could barely keep a compressor running.
Did you ever come up with that?
Yeah.
Did you ever come up with a fix for that?
The customer did not want to pay for my fix, so they ended up they have their own in-house service department. They ended up piping in a 24-foot produce case that was running on a single unit right next to it with valves, so they could just turn the produce case back on in the summertime when it overloaded the rack. So that was their fix. I mean, at least it'll work for winter. But yeah, that's one thing is you want to make sure you don't have cases going into defrost at the same time or huge loads like that. It's never going to work. I mean,
that should be.
It's never going to work.
That should be one thing you do check as soon as you're going through everything. Since you're already up in the motor room, making sure that you don't have any defrost overlapping. Danfoss, you can actually look at the whole defrost schedule. E2, you basically have to go down line by line item. Something really helpful when you're in the setup of the actual circuit, looking at the defrost times. If you hold it down to control and then hit the page down button, it'll actually take you to every single circuit, and you can actually write down every single time of when the defrosts go on to see if you actually have anything overlapping that might be causing some other case on the circuit to be slow to recover.
Yeah, that's a big one. So we're going to talk about piping real quick. And for hot gas piping, it is imperative that it is piped correctly or it's not going to work. So one thing to really watch out for is how they tie the liquids in and how they tie the suctions in. Make sure they're tied in per spec. You shouldn't be bullheading T's on the suction lines. On the liquid lines, they need to be bullheaded. But on the suction lines, they should not be bullheaded. And then you need to blow your liquid line up 2 sizes. So if your liquid line is feeding the case is 5/8, it needs to be 7/8. So you need to blow it to the 7/8 header. And then you need to have bumpers on the end that need to be the same length. So you need the ends of the case where you tee in your last 2 cases, you need to have, I usually go like 5 or 6 inch bumpers with a cap on them. So like that way the gas hits both those bumpers and makes it feed equally. I mean, that's not as important if you don't have them, if you have that individual termination. But if you do not, you need those bumpers on there. And then obviously you need to come off the bottom of your tees for your liquid, and you need to have an expansion loop. Whether you do a curlicue or you do just a bend with a bender, like kind of like you're taking off the bottom of a liquid line loop, and then you could feed your cases. But you need to have that expansion joint on the liquids so you don't crack tees. Do you got anything to add to that, Brett?
Nope.
Okay, do you want to go over like slow pull downs and stuff?
Are we still talking about hot gas?
We covered hot gas pretty good. I mean, you got anything else to cover with hot gas?
No, I was going to start on electric defrost.
Okay, yeah, we can cover electric defrost real quick.
All right. When with electric defrost, depending on what coil that you're talking about, every manufacturer has their own spot where they decide to put their termination temperature sensors. Most of the hanging evaporator, typically they like to put them. I don't know what is up with this, but Heatcraft likes to put it on the piece of metal away from the coil, and they'll just basically, whatever the termination temperature for that coil is, they'll turn up the termination temperature by 10 degrees. So if that coil will defrost properly at 55 degrees, they're going to make that termination clicks on, maybe go off at 65. But like I said, not have it on the actual coil, have it on the piece of sheet metal right before the fans are installed. I don't understand why they do that. No one can actually give me a real good answer. If it was me, where I put it is behind the first fan, closest to where the distributor is. The reason why I do it there is because, one, if you're on the fan side of the coil, you're distributor, right? So you're that's the coldest spot on the coil for sure. So even if you have a lack of liquid feed, you're still going to be able to get liquid right there at the distributor. So that part is always going to be cold. Also, never putting the termination temperature sensor all the way to the very top of the coil. I usually put it maybe a third of the way down, basically usually right above the fan motor. So in that way, you're not in parallel with the heater that's right behind it. You're not in parallel with the heater that's in the middle of there. You basically want to stay away from direct flow of heat coming out from the heaters on the
Architect.
basically, like I said, about 6 inches in from where the distributors feed, and then that way, like I said, you're not at the very top, you're not anywhere close to the heaters, and you're not in ray of any of the heat actually coming out from the heaters. And like I said, also, as long as even if you don't have a full column of liquid, you are still going to have liquid feeding at that distributor. So no matter what, that spot is going to be the coldest, and it's also going to be the last place to defrost. So you'll be solid as far as your termination temperature sensor being right there. Anything to add?
Yeah, I totally agree with the termination sensor being on the face of a coil. I mean, obviously in a case, it's going to be wherever the case manufacturer wants, but on a coil, it needs to be on the face of it. The other thing that we've been doing, and I've had tremendous success across this, we probably have over like 150 stores running these now, is we've been adding TXV cabinet heaters inside the coils. So where the TXV cabinet is on electric defrost, you always get this icing on the valve. Even though you're terminating, that valve cabinet does not get enough heat just from those return bends from the heater. This is not a problem with electric defrost or hot gas defrost, because your hot gas is actually thawing those tubes out every time. So this is only a problem with electric defrost, and it's been a problem for forever. I mean, eventually you always build up enough heat on there. On older coils, it really doesn't happen as much because they had so much heat on there. But all these newer coils, where they're trying to meet these energy standards, these DOE energy standards, they seem to not be able to defrost a cabinet all the way. So what we've been doing is getting U-shaped heaters and sticking them in there and wiring them into the defrost. They end up pulling like an amp and a half more. But I have not had to redefrost a coil that hasn't had an issue, but like that has no defrost issues. Like I haven't had to defrost another one of those coils if we put that heater in there. So we've been getting cabinet heaters made for all of our coils, and we have like custom part numbers at the shop for different coils that we see all the time. And we had this cabinet heater in there just wired into the defrost heaters, so it's on when it's in defrost, and it thaws that cabinet. And then we have no more issues with the coils icing up and growing from the TXB side, and then starting to build behind the first fan and keep building. I don't know how many times I've thawed a coil and it's like that.
So are you talking about strictly hanging evaporators, or are you talking about even
just hanging evaporators, like actual evaporators, like not cases, just like walk-in evaporators?
I mean, because I found similar. I ended up calling a guy that I know from Hill Phoenix or Hill, whatever you want to call it now. But basically, a lot of times when you have a store that goes under remodel and they go under a gas retrofit, never happened before where you had excessive frosting on the distributors, basically growing into the sucker or growing into oil. A lot of times that's retrofit or a gas conversion. You know, your nozzle might be a little bit undersized, so you get a little bit more evaporation of the refrigerant than what you typically would, and then in turn causing more frost to build up on the distributors, which then, like you said, ends up requiring that cabinet heater to keep that end of the coil from being able to defrost all that frost on the distributors. And a lot of times customers will go with that rather than having to redo every single nozzle and every single case in their store.
Yeah, I don't think the nozzles will fix the walk-ins, though. I actually think it's a heater issue. I mean, the ends of the coils don't get warm enough, because I mean it's even on the coil tube ends sometimes. I mean, on the distributor tubes. I don't think I've measured some of those cabinets, and some of them barely get above 30 degrees during defrost, just with the heater ends in there, depending on how much ice is on there. I've even seen 404 do it. Yeah, I mean, there's tons of 404 stores that I see with all that ice on there. It's an electric defrost. I think it's more, I mean, everybody wants to blame it on a distributor issue. Like, I think it has partial to do with it, but, I mean, you're still below freezing on that side. And, I mean, if it's not getting warm enough to melt that during defrost, it's a to me, it's a heater issue.
Gotcha.
I mean, we've been doing it. Like, I mean, yeah, obviously the manufacturer didn't come up with this or approve it, but like, I'll tell you what, I mean, it's saving customers thousands of dollars a quarter because I mean they're not thawing out coils that are icing up once a quarter. We're finding on PMs with electric defrost.
Gotcha. And then with going through checking the electric defrost, making sure that the bridge is actually pulling and whereabouts it should be on the IOM manual for that footage of case, or in a glass door situation would be per door. Like we said before, when we talked about the refrigeration schedule on one of these podcasts, and we were talking about how a lot of times it'll say how many feet are in the actual case. Now, the only time that's differ if you have actual glass doors. So instead of actually referring to it as being foot, it'll actually be the amount of glass doors that you have on that particular circuit.
Yeah. Case electric defrost. I mean, you tend to see the icing up. I know some customers. We have some customers that do not term certain glass doors anymore. They just let them run the whole 45 minutes or an hour defrost because they had so many issues with them not defrosting properly, which that seems to be an ongoing thing with electric defrost. I'm not a complete fan of electric defrost. If I had my choice, it'd be hot gas all day long.
No, I agree with that. It's a lot easier to play Hail Mary and throw the thing in hot gas defrost and hopes not to have to pull the whole entire lineup.
Yeah. So you want to go over slow pull downs?
Absolutely. Making sure that the case is coming down in temperature within the allotted amount of time. Unfortunately, the IOM doesn't really tell you exactly how long that case is supposed to be coming down. But if that case doesn't come down within an hour, you definitely have an issue. Making sure that the filter dryer, obviously you already did your rack checkout to make sure your liquid was at the right temperature, making sure you have a good receiver level all around the time that the case is actually going into pull down. Making sure that the filter dryers inside the cases are not blocked. That we talked about this before, but making sure that there's no more than a 1 degree temp drop across the filter dryer. Making sure that the screens are clear. If you know you already have a dirty store where you have issues with the many filter dryers blocking up, chances are you probably could have bypassed a little bit of dirt down the line, especially with running even hot gas or cool gas defrost, where you're basically bypassing any kind of filters going through into the thing itself. So you could be putting more particulate matter back into the liquid line from the discharge line, and then turn blocking up the filter dryers.
Correct. I mean, with one thing with like the slow pull downs, I mean, a lot of these controller alarms, like some of them, like I see a lot of customers put a half an hour pull down time after defrost. So if it isn't down to that alarm threshold after 30 minutes or an hour, I mean, it's going to alarm for high temperatures. So one thing you want to really pay attention to is if you got cases slow pulling down, you still need to go through the rack and make sure everything's right. Because I see this all the time. Guys instantly go to the case and start writing up valves or dryers or start opening valves up when in all reality, you got a subcooler down or plug dryers at the rack, or you don't have enough refrigerant at the rack, or you have a defrost differential valve issue or something like that. So you just need to make sure that, like, when you're looking at this, that you check out the rack first and then go to the case and then look and see if you got a restricted filter dryer or clean the screen. I mean, you shouldn't really be writing up valves. Valves are pieces of brass. Valves don't really fail. I mean, TXVs fail. They usually fail bleeding through. I mean, a piece of brass really doesn't fail too often. So, I mean, generally you could take them apart and clean them. But if you're getting slow pull downs, I mean, generally you need to check superheat and make sure that all that's correct. And another thing is making sure you got the correct fans in there, because that'll affect pull down times and everything else, and TDs and the coils. I had a case not too long ago where the service department was out there and from another company, and they changed a bunch of fan motors. Well, they put the wrong fan motors in the case. So now my airflow was almost double what it had. It was supposed to have 350 feet per minute. I was getting almost 600 feet per minute. And they couldn't get superheat out of any of the valves because the load was almost double on the coil. So that's one thing to make sure is you need to be checking your airflow with a velometer to make sure it's actually correct and make sure that you have the right fan motors and somebody didn't change fan motors out and put the wrong ones in. This same thing with RPMs. Like some Husman cases use like 2,500 RPM, or they're real weird, like 2,100 RPM motors, like 25 watt motors, but they're like the size of a 5 watt. So you need to really pay attention. In some of those cases, you can't use those ECM 4511Es. You got to use the original Husman motor.
A lot of some of the new ones also are what they're DC, they're almost like an ECM motor. They have a DC signal sent to them. Is that?
Yeah. Then another thing to pay attention to is, like I've had it on other cases, is you order a fan motor from the manufacturer and they send you out like a programmable fan motor, and they may not have programmed it right. We've had this happen a couple of times, and that motor's spinning slower than what it's supposed to be, and it's not programmed right. So, I mean, you somehow get a programming stick from somebody to verify what the RPM is on that motor, because a lot of these new cases, especially Hill Phoenix, is just sending out ECM motors they're just buying the same motors for every case, and they're just changing the RPMs as needed. So that way, I mean, they can just put whatever motor they need in there, but you just need to verify that that's the correct motor to make sure you have the correct airflow.
And a lot of times on those ECM sticks, they're really not that expensive. I think one for MPAT, the one that I had that basically covers 90% of Phoenix ones are basically what, like $90 I think I paid for it. But it saved me out of a jam from fixing a case that other contractors hadn't been able to actually find the issue. By basically going over what the air velocity should have been with FPM coming out of the case, and then seeing that, like Kevin said, where, hey, the fans aren't really spinning as fast as what these other ones are, and they say they're supposed to be the same RPM. And then throw the stick in there and then find out that it's over 3 or 500 CFM, RPM spinning slower than the rest.
So I'm going to give you one piece of advice that I learned the hard way here. Make sure you unplug that motor when you stick that EBM stick in, because it will electrocute the living crap out of you. Because you're touching that stick and it's just a circuit board, and for some reason it doesn't blow the stick up, but power goes right through the stick, right into your hand.
So are you not a big direction reader too? Because I've done the same damn thing.
Yeah, I never did directions. I just stuck a stick in the back of the thing because I was all mad when I was having to do it, because I was flipping over a bunch of case plenums a day before grand opening to increase speeds on motors that the manufacturer didn't do. So I was in a hurry and I stuck the stick in there and lit myself up. And then, yeah, I was very angry for the next half hour.
A big warning tag on there, big and orange, that says disconnect power from fan motor before plug.
Yeah, so it was a real stupid move on my part. So then, obviously, setting superheats on low temp cases. I mean, you're going to aim a lot lower than normal. So, like, I usually go 3 to 6 degrees. I mean, I try to get them down a little bit lower. That way I can save a little bit of energy and then at the same time prevent that slow pull down. So I usually shoot for like 3 to 6 degrees on my superheats. And I'm usually shooting, when I'm setting superheats, especially on low temp, I'm shooting for the low swing. If it swings to 3 and then bounces back up, I'm happy with that. I mean, I was going to hunt a little bit, but it shouldn't hunt horribly.
Great.
What's your thoughts on that, Brad?
3 to 6, 3 to 5. It's usually where the manufacturers tell you. One of the only cases that I found that will tell you to go kickstand is Kaiser Warren cases. Or no, I'm sorry, zero zone cases where they want a higher superheat. They want you up to 6 to 8 on their low temp stuff. I don't know why. I don't know if it's the way they design their coils, but that's the way that they want them. I have no idea why though.
Yeah, I mean, I don't get to see a whole lot of zero zone stuff besides their CO2 stuff. One other thing I wanted to bring up is the traps. It is very, very important that you trap all your drains on low temp stuff. Make sure there's a trap on the main run of glass doors where they're draining together. Make sure there's traps on walk-ins. If you do not trap drains, they will eventually cause the coils to ice up because it's just going to suck humidity through that drain. Same thing goes with coolers. You should always trap cooler drains too. I see a lot of guys that don't. You need to trap cooler drains too because they'll do the same thing. But with freezers, it's a lot worse.
Freezers should be trapped outside of the box, not inside. You run more of a chance of basically any sitting water sitting in there and end up freezing up. The other thing is, as well, is the freezers on the slope of the pipe is going to be more at an angle than basically like a medium temp cooler.
Yep. So I mean, trapping is very important. I see freezers all the time with no traps and continuous ice ups, and it's as simple as put a trap in, and they can take care of it.
Right, if you have nothing more about traps, I just want to talk about defrost one more time. I'd rather bring this up.
Yep.
Some manufacturers with electric defrost, you have to have a way to actually shut off the fan. It would cost a lot of money to have a relay output at every single row board back at the rack house to actually shut it off. That's why a lot of manufacturers use case controllers now, so they have better control. But there are some manufacturers that shut off the fans in different ways. Hussmann's big on utilizing the power for the actual electric heat rods to actually deactivate the fan and energize the pan heater. You always typically need a pan heater because that water coming down off the coil down towards the drain, the pan is always going to be cold, really, really cold. So if you're not heating that up, any water that you are dripping down on that pan is in fact going to end up refreezing. But you need a way to actually end up shutting off your fan, whether that be case control driven, like Kevin said, that they're utilizing instead of a regular standard click-on, they're utilizing some sort of electronic control. But as soon as those electric heaters turn on, you need something to turn off the fans. Otherwise, you're just going to be just blowing off that heat and not really letting it evenly distribute all throughout all the coils. Same way with hot gas and cool gas, you need a way to basically turn on and off the fans and turn the pan heater on. A lot of time that's done with a separate temperature control that's mounted on the coil. Some people like to put them on the actual suction header coming out there. I don't like that. My mentality is that I want the fans to kick on as soon as it gets a burst of hot gas, and I want it to be the last thing that gets cold, so we get a nice even frost pattern before we actually kick on the fans. So I like to see them mounted on the suction line, right before, preferably right near the TXV, because that TXV technically isn't supposed to be on the vertical; it should be on the horizontal anyway. Anything you want to add?
No, I agree. That's where I like to keep mine. I want those fans off as fast as I can because then it's going to defrost the coil faster. So, I mean, obviously, you went over that Hussmann stuff. I just want to go over that real quick. So the Hussmann hot gas cases use the same relay, except they aren't using obviously there's no electric defrost to trigger it. So they're using a click-on to energize the relay to kill the fan motors. So the fan motors are wired normally closed. When the Hussmann case, when the click-on the suction line energizes, it closes, it energizes the defrost relay, and then switches over to the heater and then shuts the fans off because the fans are wired normally closed, heater wired normally open. So they're just using a click-on in that case with the same relay. Those, I don't know if you've seen it, but those relays have a extraordinarily high failure rate.
Yes.
Yeah, I mean, they get moisture in them. They're not the best relay. I mean, those I'm pretty sure I have an entire tube of them in my truck.
The placement of it isn't really that great too. And just remember with any of these cases, once again, they are type 1 type cases, so they're not meant for anything above 55% relative humidity and 75-degree actual ambient temperature. So if any one of those is above 55% or above 75 degrees. As we all know, even though the glass doors, you can see through them, 99% of people are opening up the glass door to see what's in there. I can't see it. You got to open it up.
Yeah, that seems to be a never-ending issue with that. So I think we covered the case defrost overview pretty good and everything else. So I think for tonight we'll wrap it up, and then next couple episodes are going to be about oil and oil failures and oil on racks. I know a lot of guys were requesting that.
All right, guys. Well, hey, listen, you guys have a good night.